In this lecture, we'll find out the area of quadrilateral AOCD. In the drawing, we have a quarter circle. AOB is a quarter circle, and we know that the length of side AC of quadrilateral AOCD is 24 units. Side CD of quadrilateral AOCD equals to 7 units in length. And this angle ACD equals to 90 degrees. Our mission is to find out the area of this quadrilateral ACDO. So because of the fact that AOB is a quarter circle, then this angle must be equal to 90 degrees. So in any quarter circle, so this angle must be equal to 90 degrees. And point O, actually it is the center of the circle that we can create by completing this quarter circle to a circle. When we complete this quarter circle to a circle, then point O will be the center of the circle that we created. Okay, so in the next step, we join points N and D together by straight line. And we'll implement the Pythagoras theorem on the right triangle ACD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle ACD, the hypotenuse is AD. Therefore, the square of the hypotenuse is AD squared. I'm talking about the right triangle ACD. Here by PT is the equation from Pythagoras theorem. So according to the Pythagoras theorem, in the right triangle ACD, AD squared equals to DC squared plus AC squared. Repeat again. According to the Pythagoras theorem, in the right triangle ACD, AD squared equals to DC squared plus AC squared. So AD squared, that is the square of the hypotenuse, equals to DC squared. DC is 7, therefore DC squared is 7 squared, that is 49, plus AC squared. AC is 24, therefore AC squared is 24 squared, that is 576. So AD squared equals to 49 plus 576 is 625. So we will take a root out of this equation and we will get that AD equals to the square root of 625, that is actually 25. So we found out that the length of the hypotenuse of this right triangle ACD is equals to 25 units. In the next step, we complete this quarter circle to a circle. So I completed the quarter circle to a circle. Point O is the center of the circle, point A is the point of the circle itself. Therefore, OA is the radius of this circle. We define the radius of this circle as capital R, so AO equals to capital R. It's null. The next step will extend the radius AO until it touches the circle. We'll define the extended radius AO, the touching point of the extended radius AO with the circle is point M. So here we know that point O is the center of this circle. Chord AM passes for point O, that is the center of the circle. And we know that any chord that passes for the center of the circle must be the diameter of the circle. Therefore, we can write here that AM is the diameter of the circle. AM is the diameter of the circle. Here, point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is the radius of this circle that is equal to R. So, and we know that AM is the diameter, so it should be equal to 2R, and indeed AM equals to 2R. Okay. In the next step, we will extend side CD until it touches the circle. Okay. And we will assume that side D, the extended side CD, will not touch the circle at point M, but it touches the circle at another point. For example, it will touch the circle at this point, point N. So we will assume that the touching point of the extended CD with this circle is here at point N. That is different from point M. Okay, this is our assumption. So angle ACN is a peripheral angle. Why? Because here the vertex is at point C and the two legs are on points A and N of the circle. So this is peripheral angle ACN. That it is given us the question that is equal to 90 degrees. So we have here peripheral angle ACN that is equal to 90 degrees, and it rests on chord AN. And chord AN, it is not the diameter of the circle. AM is the diameter of the circle. Therefore, AN is not the diameter of the circle. So we actually found out that peripheral angle ACN that is equals to 90 degrees does not rest on the diameter of the circle. But it contradicts rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN that is equal to 90 degrees. Therefore, this peripheral angle MAN rests on MN, that is the diameter of the circle. So according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here, peripheral angle MAN that is equal to 90 degrees rest on MN, that is the diameter of the circle. So it is actually impossible that peripheral angle ACN it is equal to 90 degrees and it doesn't rest on AM, that is the diameter of the circle. So due to this contradiction, we must conclude that the extended CD will touch the circle at point M and only at point M and not in another point. Why? Because otherwise we will have a contradiction to rule number 5 that says that any peripheral angle that is equal to 90 degrees, that this peripheral angle ACN must rest on AM, that is the diameter of the circle. So in order to avoid the contradiction, we will conclude that the extended CD will touch the circle at point M and only in point M and not in any other points. Okay, so here the extended side CD will touch the circle at point M. Actually, it doesn't, COM doesn't look like a straight line, but actually it is a straight line, so assume that it is a straight line, because we just extended side CD. When we extend side CD, it must touch the circle at point M, and in that way we'll get that peripheral angle ACM that is equal to 90 degrees rest on AM, that is the diameter of this circle, exactly according to rule number 5. Otherwise we will have a contradiction, and therefore this COM is one straight line. Okay, COM is one straight line. So this is the straight line COM. So now we'll focus on the right triangle ACM. On this right triangle ACM, AM square must be equal to AC square plus CM square. But again, in the right triangle ACM, by PT is the version for Pythagoras theorem. AM squared, that is the square of the hypotenuse, must be equal to AC square plus CM square. But before that, if you focus on this side of the diameter AM at point O, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of the straight line must be equal to 180 degrees. So which angles we have at this side of AM at point O? We have this angle that is 90 degrees. Therefore, the missing angle here must be also equal to 90 degrees. In the next step, we'll focus on the right triangle AOM and on the right triangle ODM. On those two right triangles, those two sides are both the radii of the circle, therefore they are equal to each other. those two angles are both equal to 90 degrees, therefore they are equal to each other, and we have OD that is a common side. Therefore, we can conclude that the right triangle ADO is congruent to the right triangle ODM according to side angle side rule. And for the fact that those two right triangles congruent to each other, we conclude that AD equals to DM. AD equals to DM according to the rule that corresponding sides and congruent triangles are equal to each other. But AD is 25, therefore DM must be also equal to 25. Again, according to the rule that corresponding sides and congruent triangles are equal to each other, we get that AD in the right triangle AOD must be equal to DM in the right triangle ODM. Why? Because they're congruent to each other. So AMD equals to 25, DM equals to 7. So in total, MC equals to 25 plus 7, that is 32. MC equals to 32 units in its length. We know that AC equals to 24 units in its length according to what is given as the equation. Now we can implement the Pythagoras theorem on the right triangle ACM. So I copy the right triangle ACM in your page and we'll implement on it the Pythagoras theorem. AM is the diameter of this circle that is equal of course to 2R. It's given as the equation that AC equals to 24 units in length, and we just right now found out that MC equals to 32. So finally, this is the right triangle AMC that I copied from the original drawing. AM is the diameter that is equal to 2 times the radius. MC equals to 32 and AC equals to 24 according to what is given us in the question. In this right triangle AMC, according to the Pythagoras theorem, AM square equals to AC square plus MC square. AM is 2R, therefore AM square is 2R squared, that is 4R square, and it is equal to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus MC square. MC is 32, therefore MC square is 32 squared, that is 1024. 1024 plus 576 is 1600. So in conclusion, found out that 4R squared equals to 1600. We divide this equation by 4 and we get that R squared equals to 1600 over 4 is 400. We will take a root out of this equation and we get that R equals to the square root of 400 is 20. So the radius of this circle R equals to 20 units. In the next step, we'll implement the Pythagoras theorem on the right triangle, triangle AOC, this right triangle, AOD, the right triangle AOD. AO is the radius that is equal to 20. AD is the radius that is equal to 25. So this is the right triangle AOD that I wrote from the original drawing according to the Pythagoras theorem. AD square equals to AO square plus OD square. AD is 25, therefore OD square is 25 squared, that is 625, and it is equal to AO square. AO is 20, therefore AO square is 20 squared, that is 400, plus OD square. Here we subtract 400 from this equation, and you get that 625 times 400 is 225. So we found out that 225 equals to OD square. Here we'll take a root out of this equation, and we get that OD equals to the square root of 225, that is 15. So we found out that this side OD equals to 15 units. So here we have to find out the area of quadrilateral AC. We have to find out the area of quadrilateral AC, AM. We have to find out the area of quadrilateral AC, DM. The area will be equal to the area of the right triangle AOM plus the area of the right triangle ADC. The area of this right triangle ACD equals to the base is 7 times the height to the base is 24, so it is 24 times 7 over 2. 24 over 2 is 12, and 12 times 7 is 84. So the area of this right triangle ADC equals to 84 square units, plus the area of the right triangle ADM. The area of this right triangle equals to the base of the triangle times the height to the base. The base is MD. So the base is MD and the height to the base is AD. Okay. Actually, the base is OD, that is 15, times the height to the base is 20 over 2. 15 times 20 is 400 over 2 is 150. So we found out that the area of quadrilateral ACDO equals to the area of this right triangle that is equals to 150 plus the area of this right triangle that is 84. 150 plus 84 equals to 234 square units. Okay. So the area of quadrilateral ACDO equals to 234 square units. Okay. So in the next step, I will summarize the lecture. So in this lecture, we found out the area of quadrilateral ACDO, area of this quadrilateral. Again, the area of the quadrilateral equals to the area of the right triangle AOD, that is 150 square units, plus the area of this right triangle AOC, that is 84. 150 plus 84 equals to 234 square units. So I actually found out the area of this quadrilateral. AODC. Okay. Repeat again that the area of the quadrilateral equals to the area of the right triangle ADC, that is equal to 84 square units, plus the area of the right triangle AOD, that is equals to 150 square units. So 150 square units plus 84 equals in total to 234 square units. That is the answer to our question. So there, our mission is to find out the area of this quadrilateral ACDO. In order to find out the area of this quadrilateral, we join points A and D together by a straight line. Again, I repeat again that we have here a quarter circle AOB. Side DC equals to 24 units in itself, side DC equals to 7 units in itself, and this again ADC equals to 90 degrees. Our mission is to find out the area of the green shape, the area of quadrilateral ACDO. So first of all, we join points A and D together by a straight line, and we implemented the Pythagoras theorem on this right triangle ADC. On this right triangle ADC, AC square plus CD square equals to AD square. AC is 24, this is 7. So in the right triangle ADC, AD square equals to DC square plus AC square. AD square equals to DC square. DC is 7, therefore DC square is 7 square, that is 49, plus AC square. AC is 24. Therefore AC square is 24 square, that is 576. So in total, we found out that AD square equals to 49 plus 576, that is 625. So AD square equals to the square root of AD square equals to 625. We took out of this equation and found out that AD, the hypotenuse AD of this right triangle ADC equals to the square root of 625, that is 25. Okay. Then we completed this quarter circle to a circle. We extended point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of the circle that is equal to capital R. We extended the radius AO until it touches the circle at point M. Chord AM passes for point O, that is the center of the circle, and any chord that passes for the center of the circle must be the diameter of the circle. Therefore, AM is the diameter of the circle, that is equal to 2R, of course. Again, AM is the diameter of the circle. Then we extended side DC until it touches the circle. We assumed that the extended side CD will not touch the circle at point M. If it touches the circle, for example, this point N, then we will get a contradiction. Why? Because we have peripheral angle ACN that is equal to 90 degrees, and it doesn't rest on the diameter AM of the circle, but because of the fact that this peripheral angle ACN equals to 90 degrees, it must rest on AM. That is the diameter of the circle. So it is a contradiction. It is impossible that peripheral angle ACN that is equal to 90 degrees rests on line segment AN that is not the diameter. It must rest on AM because it is equal to 90 degrees. Therefore, you can conclude from it that the extended side CD must touch the circle point M at point M, only at point M and not in another point. Okay? So here, actually, CM or CDM is one straight line. You cannot see it from the drawing, but CDM, it is one straight line. Okay? Then, in the right triangle, here we have AM is the diameter of the circle, therefore it is absolutely a straight line. If you focus on this side of the straight line, AM is point O. Here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have this side of AM at point O? We have this angle is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, this angle must be equal to 90 degrees. So, the right triangle ADO is congruent to the right triangle ODC or DA. Those two right triangles congruent to each other according to side angle side rule. Why? Because AO equals to OM equals to R. Each side is the radius of the circle, that is equal to R. Those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally we have side OD, that is the common side that belongs to both triangles. Therefore those two triangles can go into each other according to side angle side rule. And from the fact that they can go into each other, we will derive that AD equals to DM. But AD is 25, therefore DM must be also equal to 25. Okay? So MD equals to 25, DC equals to 7. Therefore in total MC, that it should be a straight line. MDC should be a straight line. You cannot see it from the drawing, but it should be a straight line. MDC is the straight line MDC in total equals to 25 plus 7, that is 32 units. So MC equals to 32 units. Then we implemented the Pythagoras theorem on the right big triangle ACM. According to the Pythagoras theorem on the right triangle ACM, the square of the hypotenuse is AM square must be equal to AC square plus MC square. Okay, AM square equals to AC square plus CM square. So this is the right triangle AMC that is covered from the original drawing. AC equals to 24 units according to what is given us the equation. MC equals to 32 units. That's what we just right now found out. That is actually equals to MO plus DC, that is 25 plus 7, that is 32. This angle equals to 90 degrees according to what is given us the question. According to the Pythagoras theorem, AM square equals to AC square plus MC square. AM is 2R, therefore AM square is 2R squared, that is 4R square, and it is equal to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus MC square. MC is 32, therefore MC square is 32 square, that is 1024. So 4R square equals to 576 plus 1024. 576 plus 1024 is 1600. So in conclusion, we found out that 4R square equals to 1600. We divided this equation by 4 and found out that R square equals to 1600 over 4, that is 400. R square equals to 400. We took the root of this equation and finally found out that R equals to the square root of 400, that is 20. So the radius of this circle R, it is equal to 20 units. And what is the area of the green shape? The area of the green shape, or the area of the green shape, that is actually the area of quadrangle AODC. will be equal to the area of this right triangle AOD plus the area of this right triangle ACD. Okay. What is the area of the right triangle AOD? It is equal to the base, that is 15, times the height, that is 20 over 2. 15 times 20 is 300, 300 over 2, it is 150. So the area of the right triangle AOD equals to 150 square units, plus the area of the right triangle ACD. What is the area of triangle ACD? Equals to the base of the triangle, that is AD, that is 7, times the height to the base, that is AC, that is 24 over 2. So it is 7 times 24 over 2. 24 over 2 is 12. So in total, this expression equals to 12 times 7, that is 84. So in total, we found out that the area of the ring shape equals to 84 plus 150. 84 plus 150 equals to 234 square units. So finally, we found out that the area of the ring shape equals to 234 square units. Okay, thank you very much.